All of it began some 11 years ago when I reverse engineered my first MS-DOS games. It was done using IDA disassembler and a program I called Cicoparser. It wasn't really easy to use and compatible only with a small set of games. As a result, you would get highly portable and efficient C++ code which you could run on almost any computer, mobile phone, or even a resource-constrained microcontroller board like these two. This project just sat on the shelf with occasional updates. Until I watched the movie Tetris from 2023, where Taron Egerton is excitedly playing Tetris and asking what language it is written in.
Was this coded in Pascal or C?
That's proprietary. You like it?
I got even more curious about the answer than him, so I decided to refresh this project and find some clues. I know the answer now, but instead of going too much into technical details, let's just enjoy this showcase of game modding with new version of Cicoparser. Remember this space shooter game? Was it too difficult for you to reach the second level? Just with a few clicks you can finally see what's there. Code of the game is fully under our control, so let's get some power-ups and make it more fun. Yeah, that's it. Much better now. But that's nothing compared to what you will see next. Look at those crazy flying cats. Do you know what movie they are from? Let me know in the comments and the first correct answer will get some present from me. This is how pure gaming joy looks like. Let's see what we have next. Titus the Fox from 1992, another game running in a web browser. Note that there is no smooth scrolling since this game was designed on a poor 16 MHz PC, which was simply not powerful enough for that. Actually, if you would run this game in DOSBox, you wouldn't notice any difference. So the question is, why did I put so much effort on a converter which can reverse engineer 30 years old games? Because I had no family and too much free time. With just a few changes in the code and with the help of HTML5, we got this. High-resolution animations, smooth scrolling, parallax, even the music track was remastered. Game layout was split into few layers. Top 1 holds animated GIFs of light and toxic steam from sewer. Second one contains the game characters, enemies, objects or everything non-static. Game map was upscaled with external tool and split into 3 images which create nice parallax effect. Last layer is just the sky. Now let's watch it in reverse. GIF animations are blended with lighten mode to make them look transparent. Game characters and objects is the only part which is rendered from the game. Backgrounds are rendered by HTML and their horizontal position is just moved by the player position. This is a demonstration how you can make remastered HD versions of old games while keeping the game mechanics untouched. Again, you can play this game directly in your browser and easily switch between levels. How cool is that? Previous games were written in pure assembly. So when you look at their disassembly, it's fairly easy to read and every instruction gives sense and does something visible, but this one is in Turbo C. Higher languages introduce common runtime routines and teaching Cicoparser how to work with them was a tough task. Even when the game itself looks pretty ancient. Adding support for Turbo C opened door to port a whole bunch of more recent games. Innocently looking game, but with mind-bending puzzles. Game was modified to be controlled externally, so I can instantly switch between levels. To add a community element, every time someone finishes a level, the keystroke sequence is sent to my server to keep track of best solution for each puzzle. All of the solutions can be later replayed at your browser, as you can see now. If you wonder how such sequence looks like, here it is. Just a bunch of pairs of numbers where one is the timestamp and second encodes the pressed buttons. The more complicated the level is, the longer the path is. That's all it takes to replay a level. But if the level is too difficult for you, you can ask ChatGPT for help. In this case, game is running at a much higher frame rate so that the AI has more time to observe the game mechanics. Let's start with a few simple queries so the AI can learn how to survive the game, and learn the game objective. After a while, ChatGPT is trained to quickly solve the puzzle. ChatGPT Lite with the interactive interface is available only to close group of developers. Ask for evaluation access at chatgpt.com. Let's switch to multiplayer games. Tunneler was written in Pascal and uses undocumented video graphics mode. Surprisingly, it was much easier to emulate than a regular EGA that games of this era use. Objective of this game is simple: find and destroy your opponent by digging holes in this huge map. By reverse engineering the game, I reconstruct the whole map, which you can see on the bottom. To make it even more fun, I have included a maze in the map. By sharing the keystroke sequence as we have seen in Bumpy with another player in real time, we are getting a network multiplayer game. This game was written back in the days when the internet was still a new thing, so with Cicoparser you can do really amazing things. There is no limitation on how many users can be connected. In this case, there are 2 players and 1 observer. All of them have opened the same URL and all instances are perfectly synchronized. If you want to see what's under the hood, Docker file with the server is available on my GitHub. Now the boring part. I will try to briefly explain how this works. If you are not interested, just skip to the next chapter. Cicoparser takes executable of MS-DOS application and with the help of Capstone disassembler, it turns it into C++ source code. But this single file is not sufficient to run the game. You will need to provide few more files, which tells the game how to map the keyboard, how to emulate the video adapter and CPU. Produced code is just a simple subset of C++ and can be easily transferred into JavaScript. Again, by passing few more files you will get a working game which you can put online and play directly in the web browser. The most feasible target, by my opinion, is WebAssembly. Even in the web browser, it provides almost native speed while keeping the CPU load very low. By the way, WebAssembly modules are very simple to integrate since they have a very clean interface. Internally, most of the games require less than 1 MB of RAM, but they need some limited access to the file system. I usually embed all of the game resources as base 64 strings into one huge JavaScript file. Regarding the interface, for each frame you will pass the list of pressed keys on input and you will instantly get frame buffer on the output. Now, let's say there is another player playing the same game. Instead of sending the keystrokes into the WebAssembly, it goes through a cloud service which merges data from all players and sends them back. Everyone would see exactly the same. But unfortunately, it takes some time to send data back and forth, so every player runs 2 instances of the game. One is the real-time, which is directly controlled by the user, and the second one is synchronized with the cloud server to the very last bit of memory. They are identical, but delayed by a few frames against the real-time instance. Then, periodically the synchronized instance copies its state into the real-time and missing frames are appended. For the remote player, we need to predict which keys might have been pressed until we will get another update from the cloud. And for the local user, we keep track of what and when he pressed. And this is exactly how any Cicoparser game can be turned into online multiplayer game with a few clever tricks. Note that Dynablaster is the only VGA game you will see in this video. And in the web port I have included a nice mod which allows you to control all 4 players by keyboard. In the original version it was limited to 2 players and 2 more could play on joysticks. I tried to port this game into Swift and Objective-C to see if it would be playable on phone, since this game itself didn't have any mouse support and the player was controlled solely by keyboard. I had to add some simple pathfinding algorithm that would work with touch input. By clicking or tapping on the map, Pac-Man automatically goes there by following the shortest possible path. If you wonder how this was done, watch this animation. Map with obstacles and Pac-Man coordinates is extracted from the game memory. We will start traversing the map at the point where we clicked until all reachable blocks are marked. Then we do a little trick. Let's swap the direction of all arrows. Now every map cell shows you which direction to go to reach the target. And now let's see it in action. Pure magic! Another popular game from early 90s. This time, no special modding was done. Just watch the URL. By altering it, you can jump between levels and screens. The top panel shows you extracted values from game memory such as score, lives, health, and remaining time. Cicoparser does the heavy lifting and transforms more than 99% of the game instructions into C. But there are still some places which need to be fixed by hand. At least with current version. Sometimes the machine code programmers use strange tricks which are very difficult to implement in C or C++. Like in this case, they use context switching mechanism and they are dropping multiple stack entries to exit from the 3 nested functions instantly. This is what they do after you finish the level, and I gave up trying to find some workaround how to emulate this behavior. Another challenge was Pascal with Borland's graphics BGI drivers. These applications load external driver into memory and call routines from it. Again, this is something that Cicoparser doesn't support for now. This game looks like you could code it in one afternoon, but it is special for me. At one creative team building at previous job, we even made a gaming console to play old games like that. I remember playing Cherry at every coffee break every day. Our boss wasn't exactly happy to see that, but these are the little things that help to build friendly and more productive workplace. Great thing about this is that up to 6 players can play the game at the same time. And if there could be 10 players, I am sure we would squeeze in front of this machine and enjoy this massive multiplayer game. Thank you, Branio, for sharing these photos. In this game, you lead 50 or more small creatures into a portal. There might be various obstacles which you need to dig through or climb. Booby traps and limited amount of special tools makes this game pretty difficult in higher levels. And of course, you need to save them before the time runs out. At first I was thinking that as a mod I will create custom rules to finish the level. Like for example, you need to sink in water at least 5 players, reach the highest point in the level and explode there. But then I decided that I will make a painting program from it. Playing Lemmings while drawing custom level makes it completely different experience. Many of these old-fashioned games require a very precise timing and character movement. This may get a bit annoying, especially if you are just a casual player and you need to restart the whole level just because of small mistake at its end. Can we slow down the gameplay? Yes, we can. Can we stop it completely? Yes, we can. Can we reverse the time and travel back? Let's try it. Similarly as with the multiplayer game, here we have 2 game instances running. One is real time and second one is few seconds delayed. If you press left shift, alarm clock will appear, the game will slow down and slowly start reversing. During reversing, you copy the delayed version into the real-time one and apply missing keystrokes. But the trick is that we apply every time less and less keystrokes. This makes an illusion that you are traveling back in time. After you release the shift key, the game continues as usual. To see how quickly we are running, I have made this little test. What you see right now is the sequence of keys for Rig 2 to finish the game completely. The last frame number is 48,000, so that is a pretty long recorded sequence. Now, instead of playing the game, we will pass proper list of keys for each frame to the game engine and dump the frame buffer into std out. This will allow us to feed FFmpeg video encoder with the actual gameplay. While encoder is crunching on our data, let's see what was printed at the beginning. We run the game 3 times in a row and check how long it took. Can you see it? Below 1.5 seconds on a 4-year-old MacBook Air M1. That's incredible! And if you do the math, that means the game was running at 30,000 frames per second. That's completely crazy. And check this, FFmpeg finished the encoding and we have this nice long video of the complete Rig 2 gameplay. So let's now enjoy the final fight with the boss. And if you would like to try Cicoparser by yourself, go to the project home, go to the games library and you will find there all of the games I have ported so far. Let's try Rig 1 for example. Here you see a bunch of shell scripts. Fetch downloads the game from public sources. A folder DOS with the game will appear. Cico.sh converts the game and applies a patch with some extra changes. In this case, we can enable or disable some options to make the game easier to play. The result is stored in this CPP file. The final step is the run script, which will compile the game and run it. This works nicely on Mac if you have SDL2 and Capstone disassembler installed. For those who prefer Windows or Linux, I have prepared two demo scripts. For Windows, it is a regular batch file that does everything automatically. It downloads portable version of MinGV compiler, Capstone disassembler. It also downloads the Cicoparser code, which is just a single C++ file. Then it downloads the Star Goose game, converts it, and runs the game. As a bonus, it also creates WebAssembly port. For Linux, the Docker file is less generous. It does basically the same, but without the WebAssembly port. Porting a game with Cicoparser isn't always straightforward, but I've made a tool which helps me with that. As we have seen before, Fetch downloads the game, we have their single exe file and a few resources. If you look inside the executable, you will see the famous MZ header. Coverage scripts uses Cicoparser to generate C++ code of the game, but including a lot of extra information which we can visualize with this HTML file. Right now we are looking into the guts of the exe file. Every block represents 128 bytes of the file. Green bubbles are identified functions, purple is the data segment, gray filled blocks are zero filled empty blocks. Clicking on the first block reveals the first bytes of the exe file and how Cicoparser transformed it into C++. This light green bubble spanning over two blocks is the entry function, or the code which gets executed as first. On the right you will see the disassembly, on the left there is the C code. And as a bonus there is the call tree and hex dump. This brown bubble marks the jump table. Usually it is referenced by surrounding code. Here you can see something that is called an indirect jump, or a complete nightmare of porting. On the left you can see that it was nicely transformed into switch statement. Unfortunately, this is something that is difficult to do automatically, and you will need to guide Cicoparser a little to get similar result. For an indirect jump, you need to mark the address of the instruction, then you need to provide the starting address of the jump table, type of the entries, and their number. So these are the command line switches we need to pass to Cicoparser to properly turn indirect jump into a nice switch. Coverage tool also marks blocks which are not completely covered in dashed line. We can see here a chunk of bytes which is definitely a code, but unfortunately it was not referenced anywhere. This might be a code referenced by some indirect jump, or maybe a forgotten debugging code, or probably something related to redefining the player keys. After all, it doesn't seem important for the port, since I was able to finish the game even without these small uncovered gaps of code. So to conclude this very time-consuming and non-profit project, here are some bullet points. In general, Cicoparser can be used to port some 16-bit real-mode applications. It does not do it automatically, it will need your help, but as a reward, you will have the source code which you can freely modify. Currently, it produces C++ code which can be executed as native application or used to build WebAssembly module. Generated code can be also easily transformed into JavaScript. Coverage tool helps to identify jump tables and code gaps. C++ or WebAssembly ports have very simple interface and integration into AI frameworks, or as a minigame inside some 3D shooter game is also possible. This video shows that regarding modding you can go completely crazy. Since we have quite optimized C++ code, the game runs very quickly on modern computers. This speed is also very important for training AI agents. With DOSBox which runs in real time, this would be completely unimaginable. And if you need lightweight code without any dependencies that produces hours-long temporally coherent video for testing video encoders or testing a machine stability, this is what you have been looking for. So, thanks you my friends, and I hope you liked it, and don't forget to tell me what game you would like to see ported in the comments.